This video is intended to be instructional for contractors performing work in the state of Tennessee at petroleum underground storage tank sites, and specifically addresses soil gas survey samples. Technical Guidance Document 018 is available on the Division's website. It is recommended that you review this document in detail prior to conducting a soil gas survey in the state of Tennessee for petroleum underground storage tanks. A few key points to remember when planning a soil gas survey. Only analyze soil gas samples for COCs above the SSCLs, isopropanol, the tracer, oxygen and carbon dioxide. Analyze COCs using method TO15 for a fixed laboratory or 8260 if on-site analysis is conducted. Soil gas surveys are not applicable at sites where the soil contamination above the SSCLs are at depths of less than 3 feet. Soil probes are not required at locations where construction is prevented by zoning restrictions, setbacks, right-of-ways, or utility easements. Soil gas surveys cannot be conducted when the water table is within 3 feet of the surface at the time of the survey. Soil gas surveys may not be conducted within 48 hours of a significant precipitation event. And a maximum of 8 locations in one day's field activities may be proposed in the soil gas survey application. If additional soil gas samples or time is needed, compelling justification will have to be provided to the Division. All Summa canisters, regulators, sample trains, or any other part of the soil probe must be transported in a petroleum-free clean container. All drive rods, expendable or retractable points, or other metal parts should be decontaminated according to the Environmental Assessment Guidelines, Section IA-9. As with any other environmental sampling process, clean disposable gloves should be used to prevent contamination of the sample. Gloves should be changed any time there is a chance of compromising a sample during the collection process. To ensure that all relevant data is collected, always use the soil gas survey field log provided in Technical Guidance Document 018. Although different configurations of soil probes are used, the typical probe consists of a drive rod with an attached point holder and expendable tip. Following insertion of the probe into the ground, the drive rod is either removed entirely, leaving the nylon tubing for sampling, or the drive rod is lifted approximately 3 inches to allow soil gases to flow into the probe. The soil gas is extracted via new 3/8 to 1/8 inch nylon tubing. Typically 1/4 inch nylon tubing is used. Disposable plastic quick connections available at most hardware stores complete the train as shown. The sample train may only be used once and is disposed of after sample collection is completed. It is recommended that the sample trains be assembled prior to arrival on site and properly stored to avoid contamination. The sample train is attached via a regulator to a 1-liter Summa canister as shown. A clean regulator must be used for each sample to avoid cross-contamination. The regulator should be preset by the laboratory to a maximum flow of 200 milliliters per minute. The pre-cleaned Summa canister are typically shipped from the laboratory with a hard vacuum of 29 inches of mercury. Each canister will have a unique number assigned by the laboratory which should be referenced in the chain of custody. Although soil gas probes may vary in materials of construction or installation process, many begin with drilling through concrete or asphalt cover. Once the cover is removed, a percussion hammer is used to drive the probe to the desired depth. The probe is then lifted 3 inches and a center rod used to make sure the expendable point is free, allowing soil gas to enter the probe. A barb with attached nylon tubing is then lowered into the drive rod and rotated to seal. Another common method of soil probe installation is the use of a hammer drill, as illustrated. The drill is used to penetrate the surface cover prior to installing the drive rod into the soil below. This technique is well suited to UST sites where access is limited. In this particular design, the drive rod is removed after installation, leaving the expendable point in the ground at the desired depth. The nylon tubing attached to the point extends to the surface for sampling. A similar technique uses a slide hammer to install the probe to the desired depth. This technique is very portable and especially suited for soil depths of 3 feet. A variation of this technique is the use of a metal conduit or pipe with a removable center rod which may be driven to the proper depth. The center rod extends about 3 inches below the bottom of the pipe or conduit and once removed leaves an open space at the bottom for soil gas to enter the probe. A small piece of flexible tubing with a reducer, or if the pipe is threaded at the top, a metal or plastic fitting may be attached to allow for sample collection. Regardless of the installation technique used, it is important to properly seal the probe to prevent migration of ambient air into the sample train. Either petroleum-free modeling clay or a hydrated bentonite with the consistency of modeling clay should be pressed around the drive rod, conduit, or nylon tubing at the point it leaves the ground surface. In this illustration, bentonite has been used to seal the nylon tubing after the drive rod has been removed. For installations where the steel drive remains in place during sample collections, the seal is applied around the drive rod as shown. Following placement of the seal, a Summa canister with regulator and sample train is attached to the nylon tubing in the soil gas probe. The next step is to conduct a vacuum test. A short 2-inch segment of flexible tubing is attached to the sample train in the vacuum pump. With the valve of the probe closed, a vacuum of at least 10 inches of mercury is created. The vacuum must not decrease for 2 minutes to demonstrate that the sample train is leak-free. If the vacuum test fails, then check the connections and repeat as necessary. Following the vacuum check, open the valve to the probe and purge 3 volumes to ensure that the sample is representative. If using a hand pump, slowly squeeze the handle the required number of times to complete the purge. The flow during the purge shall not exceed 200 milliliters per minute. Following purging, turn off the valve to the vacuum gauge while minimizing movement of the sample train to prevent leaks. A tracer is then applied around the nylon tubing or drive rod at the surface seal. Lightly spray isopropanol on a paper towel and lay this at the ground surface. Do not apply tracer over the entire sample train, as this increases the chance of creating a false positive. Remember, the nylon and PVC connections have already been pressure tested and do not need a tracer. After applying the tracer, your gloves must be changed before beginning sampling. Turn on the valve to the Summa canister and record the time in inches of mercury vacuum on the canister gauge. The vacuum of the canister will slowly decrease as the soil gas enters the Summa canister. Most 1-liter canisters take from 5 to 20 minutes to fill depending on the permeability of the soil. If the canister takes more than 30 minutes to fill or the initial canister vacuum is low, replace the regulator and Summa canister and repeat the test. Regulator failure is not uncommon, so you should be prepared and have 2 regulators and Summa canisters more than the number of sample points proposed. During collection, if water droplets are noted in the sample train, stop collection of the sample and note the presence of water in the field log. Once the sample is collected, close the valve to the Summa canister. Record the time and final vacuum of the canister. Install any laboratory-provided Summa canister caps or covers. Label and fill out the appropriate chain of custody, and complete the soil gas fill log. Unlike most other environmental samples, 1 field duplicate sample is required for each sampling event. The duplicate sample should be collected at the sample location presumed to have the highest soil gas contaminant concentration. Unlike most other environmental samples, Summa canisters should be stored at room temperature and not on ice. When selecting the depth of probes, remember, if no structure is currently present or the receptor building is of slab-on grade or crawl-space construction, soil probes shall be 3 feet in depth. For buildings with basements, soil probes shall be installed at a depth of 3 feet and 10 feet. If water is encountered at a depth of 4 to 10 feet, then a probe shall be advanced and sampled at a depth of 2 feet above the water surface. Up to 7 probes may be installed adjacent to existing or potential receptors. Probes will be located 3 feet from the receptor for slab-on grade construction and 5 feet from basement or crawl space foundations. Probes should be installed along any receptor structure which is adjacent to or downgrade from soil or groundwater contamination. Any wall or structure exceeding 50 feet requires a minimum of 2 probes. The source area may be defined with up to 4 points, which should be at least 5 feet from any excavation filled with sand or gravel. 1 soil probe may be installed beside any utility trench that crosses the source area and intersects a receptor. Utility trench probes should be located 3 feet from the trench and 3 feet from the slab-on grade or crawl space building, or 5 feet from a basement receptor. This concludes the soil gas survey sampling tutorial.